Hello everyone, welcome back to the 5 Minute Tech channel. Today we will be talking about implementing AI-driven microservice orchestration with Semantic Kernel and Ollama. This is the second part of the series in which we are talking about how to orchestrate microservices with a local LLM brain. So this is an AI native e-commerce platform where we have an application running on Blazor UI, and we have API gateway through which we interact with the AI orchestrator platform. This AI orchestrator is based on Ollama along with Mistral AI model, which talks with semantic kernel, which is the planner, and generates the synthesized response in terms of JSON plus the AI narrative. It has 4 services at its backend, which is product service, order service, discount service, and notification service. Each of these services have their own database or the queue for the notification service, and they provide the data for the AI orchestrator to talk with the user running on the Blazor UI. And the application looks something like this, where you have this is the admin URL for the admin user for this application, wherein we have the AI command center and the different products which user can go ahead and add to the cart, whereas also there is a command center which user can use for things like prompt for the specific fix most expensive stock issue, and when he clicks or sends it across, there will be the AI orchestrator in between which will orchestrate the response to the user in terms of what were the most expensive stock issue for the admin user here for the different products which are listed in this application, and it will return you with the specific products with the product ID that we're having the expensive stock issue. And then similarly we can have some prompts, example, identifying the best selling product category, for example. So here also the AI orchestrator will come in picture, and it will go ahead and pull those details from the database along with using the semantic kernel, and as you see you will be getting the best selling product category with the details around it. So let's go ahead and code this application and see how we can orchestrate this implementation. So to begin with, we'll create a folder wherein we'll go ahead and open the terminal. So we'll open the folder terminal here and we'll create a solution. So this will create a solution file, and following that we will add the different projects. First is the UI. We added the Blazor based UI project, and then we will add the API gateway. Next is our web APIs, different services beginning with the product service, then the order service, followed by discount service, and the notification service. Finally, we will be adding the AI orchestrator. AI orchestrator will again be a web API itself, and then we'll go ahead and add these projects to the solution one by one. So I've gone ahead and added these projects to the solution. Now let's open that in the Visual Studio. So I'll navigate to the folder and I'll open the solution file. It loads the application with all the projects in place. I'll go ahead and just build this solution. And everything builds fine. So we'll go ahead and add other files in this project now. After building the project successfully, the next step is to go ahead and add the Docker Compose file, which we will do now. So this Docker Compose YAML file will contain all the projects, starting with our Postgres DB, followed by RabbitMQ bus, messaging bus, the Ollama AI, the product service, order service, then followed by discount service, the notification service, AI orchestrator, API gateway, and then the Blazor UI. So we'll begin with the AI orchestrator service. I've added the dependencies which we'll be using, which are these, and it is basically around the semantic kernel dependencies. Now we'll go ahead and make the changes and I've added the two folders, the plugin and the services folders, and the program CS is where we will be adding the standalone APIs. So let's get started. The first step is to add the Ollama related implementation, where I am getting the specific model which I'll be using, which is the Mistral model, and the specific endpoint on which the Ollama will be running. Along with this, I'll be needing a specific plugin which I'll be adding now. So let me go ahead and create this plugin. Now this plugin will be calling two HTTP client classes for product and order, because they will be the two targeted areas for our AI orchestrator service. Now these services, these client implementations are specific to getting a call to a API endpoint call to the specific service, which is order, and also to the product, and getting the information depending on the configuration that we are providing. So the e-commerce plugin will take that output from the specific API call and do a serialization of whatever we are getting from those API endpoints, and that is what we will be using in our program.cs. So I'll just include that. Now we will go ahead and add the handlebars planner with the specific configuration to allow loops, and this is again for evaluation purpose, as we are using a preview version, and so that's why we have to provide the disabling for the warning which we will be getting. And then we will add the usual stuff, wherein we are adding the endpoints, API Explorer, and the Swagger specific changes. And then we will go ahead and add the specific APIs, which in our case is API A/AI/ask, and it takes the kernel object along with the e-commerce plugin object along with the HTTP request. It does a request to the specific endpoint, and it also tries to generate using the prompt which is provided to the Ollama running on with the model Mistral, and to this prompt it is able to get the response which you got from the specific API endpoints for product and order, and then take the output of that and give it as a response to the user in terms of the generated response which comes back. So as you see here, the chat completion service is taking the required services from the kernel being your the kernel object coming from the semantic kernel, and then it takes the result and then it provides the response as a JSON response back to the UI or the calling function. In our case, the calling function will be a API gateway endpoint which will be relaying it to the Blazor UI. We'll save these changes and we'll go ahead and add a Docker file to this project. So the Docker file is something which will be used by the Docker Compose to run and build and run this particular project. Last but not the least, we need to update the app setting with the endpoint for not only the Ollama but also for the product and order services. Next is our API gateway service, which will be the interface between all the services and the UI project or the UI layer. So let's go ahead and add the changes to the API gateway, starting with the dependencies. So these will be our dependencies, the Ocelot being the primary one on which we will be running our API gateway. Our program.cs file will have basically just reading from the Ocelot JSON the configuration which we have provided, which will be the endpoint specific routes. So if API products is there, then the upstream path is products, and similarly for orders, discounts, and the AI orchestrator endpoint as well. So this will be our Ocelot JSON, and also we will provide a Docker file for our Docker Compose to build and run the API Gateway project. Next is our discount service. So we'll go ahead and add the dependencies here. So we will be using Entity Framework core for pushing our changes to Postgre, and for that we will be adding those dependencies. Also, we will have two folders, one for data, that is the DB context for the discount, and also we will have the discount model with the basic properties of ID count, amount, and is percent. And in the program.cs we will be having the connection string code along with the setup wherein we are allowing the discount context data to be called along with other Swagger plugins, and also we are registering the DB context for the discount, and then we have certain endpoints which we will be using in for the discount specific calls, the API discount, and passing a specific discount code. And this is something which you can run, so you will have to run the migration, the DB migration for this. So if you're trying to work along, then you will have to run the EF core migration for this project. And the thing is, it has to seed the data which you can have at the start, a certain set of dummy data which you would like to have to test the application. Also, we will have the Docker file for this project as well for building and running the application, whereas we also have the app setting which points to the endpoint of the PostgreSQL which you will be running for this specific database. So this is about the discount service. Next we will move on to the notification service. The notification service will have these dependencies, as we'll be working with RabbitMQ client in this project. We'll be having a RabbitMQ consumer class for this one, wherein we will be having the configuration done along with initializing the RabbitMQ with the host username and password, creating the connection factory, and then doing the specific relay of messages through the RabbitMQ. This is basic boilerplate code. There could be more changes as you want to increase the way the messages are handled in the project. And as usual, we will have the Docker file which will have the building aspect of this project, and the basic program file wherein we just get the specific endpoint to check if the notification service is running, and then the app setting which has the RabbitMQ username password setup. Next is our order service, and the dependencies are similar to what we had in the discount service, and it is towards the Entity Framework core migration, as well as RabbitMQ client is an additional one, because here we will be relaying the messages from the orders to the specific services which we need. So we have added that dependency. Now let's go ahead and add this other code for this service. So we have order DB context in a data folder which has a pointer to the two model objects, models, and which we have in our project, which is order and order item. These are simple classes with limited number of properties. And then we have the services, the RabbitMQ producer, the producer of the message, wherein we are sending a specific message to the message queue, and a message producer interface, which is what we have implemented via RabbitMQ producer. Also, along with that, we have provided the app settings for the connection to the order service order DB, and then we have the RabbitMQ connection endpoint. Also, we have the Docker file as usual, along with the program.cs, which does the basic the seeding of the data, the wiring of the Swagger, and then the two endpoints, which is the API orders and API orders summary, which is what will be used to return the data with respect to the orders. So that's the basic wire-up for the order services. Next is the product services. We'll go ahead and add the dependency for product services. Again, the set of dependencies are almost the same related to EF core and the Swagger, Swazbuckle ASP.NET core. Again, here we have the data folder which has the products DB context, and it has the model which it refers to with simple properties. And in the program.cs we have the three endpoints for products, products by id, and the post of products. We are having a similar setup wherein we have the Swagger UI and the seeding of the data to the PostgreSQL, and that's one thing. And then we have the app setting, which is pointing to the products database, and the Docker file, which is used to run the project, to build the project. Next we move on to the UI project. So for the UI project we have the fonts, bootstraps, and other implementations, where we have the bootstrap bundle main.js. We have the bootstrap fonts, which is here, not here, it's in the fonts, and also we have the bootstrap min narrated, and along with that we have different components. Page wise we have the home.razor page, which is the main page where we will be landing when we go, and the basic CSS and HTML stuff here, and we are looping through the different set of messages which are there. When you ask the AI orchestrator specific questions, we'll be giving that data along with the products list. So if there is a product, there is a list of product, then it will be displaying that. And that's pretty much how it loads, and the code is the behind code which gets the data for the list of product, the basic Blazor code stuff here. Along with that, certain supporting pages in terms of app Razor loading all the dependencies, and then we have errors and products page, which lists all the products one by one. And then we have the basic app settings, which is pointing to the API gateway endpoint. Remember, there is the UI will only talk to the API gateway and not other services. And similarly we have the basic plugin for the calling the endpoint for the API gateway, and also the basic Swagger stuff. Along with that we have the Docker file and the app setting, which we already talked about, pointing to the API gateway. So this is the project, pretty much the entire project. The way to run this project is through the Docker Compose YAML file, which I showed you at the start of the changes which I was showing. We'll go ahead and run this project. So we'll go to the directory and open the terminal there and run the Docker Compose up -d minus build. So let's run this. So once your build is successful, you should be able to see something like this with all the application listed, either started or in the healthy state. Now we'll go ahead and check that the Docker desktop and see that all services are working fine. From here itself we can launch the application, the Blazor Web UI application. And here is what we are getting. We are getting the AI command center along with the list of products. Now we can go ahead and query the AI command center for whatever information we need specific to different types of use cases. For example, we are trying to optimize a low stock order. I am logged in as an admin user, and I just want to check how to optimize the low stock order. So the way we can do it is, for example, if I put a command prompt like this, whereas the quantum laptop has low stock order, find the oldest pending order for this laptop, increasing the priority and applying 10% discount for the delay. So that's something which I can send to the LLM, and it should be able to give me an appropriate response. So the LLM comes back with the answer that I have located the oldest pending order for the quantum laptop and applied the necessary changes. Here is the updated information, the order ID and the total price before discount, and then after discount what will be the price. So this way it is able to make certain reasoning. And then another use case would be wherein I want to do a dynamic sale analytics and reporting. So I want to identify the best selling product category. So I'll probably go ahead and put some prompt like this, wherein I go ahead and ask it which product category has generated most revenue this quarter and what's the average discount applied to items in that category. And when I fire this, I should be able to get an appropriate response around this. And the response comes back as the product category that has generated the most revenue in the quarter is electronics, and the average discount applied to the item in this category is approximately 10%. Similarly, there could be a scenario wherein we want to do some proactive system monitoring and suggestion, and as an admin I have access to see certain details which I would require to make the system better. So the use case would be like, for example, fix the most expensive stock issue. So we can put some prompt like this, wherein we are saying to the LLM or the AI command center, we need to address the most urgent stock issue, find the product with the lowest stock that also has the highest price, then draft a notification to reorder the stock, and it will go ahead and check my inventory and find out the, the the product with the lowest stock. So as you see, it comes back that the product with the lowest stock and the highest price is currently this product. It is currently in stock in 5 minutes and its price is this one. Here is the draft of the reorder of the stock. So this is the way in which the program can relate to a specific data or the API response it gets from the system and manipulate the response which comes back according to user's need, and that will help the developer, that will have the product going in a long run in servicing the customer. So that was all about the implementation. I hope you like the video. If you like the video, press like and subscribe to the channel. Have a nice day.